Hey guys, it's Nir. This video is the second part of the 2.5D game tutorial. In the introductory part, we created a basic scene with 2D art in a 3D environment. In this part, we will write a shader to resolve the depth issues that appeared in the scene we created. As we observed in the previous part of the tutorial, moving the camera results in rendering order glitches. This issue originates from the way Unity renders sprites. In each frame, Unity determines which sprite to draw in the front based on its distance from the camera. Although the sprite renderer has options for sort point, both do not solve the issue. To solve this, we will create a shader for rendering our sprites. The main difference is that it treats sprites as full 3D objects and sorts their rendering by depth. Our solution is using the universal render pipeline. Note that a similar approach can be applied to the default render pipeline as well. A pleasant outcome for our rendering approach is that it also unlocks the possibility to create effects such as depths of field, fog, and more. Our custom sprite shader will be a modified version of the Unlit shader from the universal render pipeline. Also, we need to change a few files that the shader depends on. Let's begin by going to the universal render pipeline repository on GitHub. The link is in the description. Choose the appropriate branch of the universal render pipeline. I'm working with Unity version 2019.3, so I'll select the matching branch. Go to the universal render pipeline directory. Its full name is com.unity.renderpipelines.universal. We need to copy one shader file and 4 supporting files to a new Unity project. From the shaders directory, copy the following files: depth only pass, Unlit, Unlit input, Unlit meta pass. Now, go back and select the shader library directory. Copy the file surface input. You should now have a Unity project with a duplicate of the following files. Rename the file unlit.shader to unlitsprite.shader and open it. On the first line, add the word sprite after unlit. Comment out or remove line 22 to prevent any collision. Change line 32 to zwrite on. The shader will now write to the depth buffer and prevent the glitches. Change line 33 to call off so it could flip sprites. For the shader support with the Unity sprite renderer, we need to change the property name basemap to main text on lines 5, 82, and 94. Let's also replace line 97. I found this line to yield unstable results, so let's replace it with clip alpha minus cutoff. It will hide the transparent pixels. The shader won't compile yet. We first need to modify the supporting files we have duplicated. Let's begin with the file depth only pass. As in the previous file, change basemap to main text. It appears on line 27 and 36. On line 36, also change sampler basemap to sampler main text. Moving on to the file unlit input. At line 7, change basemap st to main text st. At line 4, change the include statement to remove the full path and only include surface input.HLSL. Next, in the file surface input at line 8, change both appearances of basemap to main text. Now, for the last file, open Unlit meta pass. You already know what to change. Basemap appeared 3 times on line 29 and 36. Change it to main text. Finally, go back to Unlit Sprite. We need to change the include statements to use our modified files. We have include statements on line 133, 134, 153, and 154. Go to the end of the file on line 159. Change the fallback shader to hidden/internal error shader. The last thing, comment out the line below the previous line, so we won't use the script or render pipeline material editor. We finished modifying the shader. Let's create a material for it. Right-click on the shader Unlit Sprite and select Create, Material. Name the created material Unlit Sprite. We can now use the material on all of our sprite renderers. Before committing to this solution, it's essential to recognize a drawback it has. To draw the sprites as opaque objects, we use the alpha clipping method. This hides the transparent pixels based on their alpha value. It's recommended that your art assets have near sharp edges to prevent artifacts. If you prefer not to go through modifying the shaders on your own, the source code of the shader and Unity project is available to download through GitHub, link in the description. In the next parts, we will create 2 more shaders using Shader Graph. The first shader will allow us to combine 3D into our game harmonically. The second shader will enable opening doors and gates without them getting stuck in the ground. Be sure to like and subscribe for more tutorials of Unity and Spine.